Alright guys, so tonight we're going to discuss acids. Acids are the last part of the pieces of nomenclature. So if you go back to the original flowchart, the first question you're going to ask yourself is, do I have an ionic compound, a covalent compound, or an acid? Well, how do we distinguish what an acid is? An acid, by definition, is a compound that gives off hydrogen ions when dissolved in water. The key word there is hydrogen ions. Hydrogen is found in family 1, so typically hydrogen takes on a +1 charge. So the first thing that acid is going to do is it's going to have hydrogen in them, but you're going to find hydrogen in that cation position. It's going to be the first thing you see as you look at the compound. The hydrogen is going to be bound to another nonmetal or some other polyatomic anion. Now, the hydrogen has nothing to do with the name. It's all about the anion, what determines the name. So, if you see that there's hydrogen in the cation position, all right, you recognize that it looks ionic, but the cation is hydrogen. The next question you have to ask yourself is, all right, I have an acid, but is the anion by itself, or does the anion have oxygen in it? All right. Basically, what I mean by does the anion have oxygen in it is, are one of my polyatomic ions in the anion position? We're going to go through the nomenclature rules for the binary acids first. All right. A binary acid is not going to contain oxygen. So a binary acid can be any of the elements. So if I look at the nonmetals, binary acids could be HI. An iodine is just an element. We could have something like H2SE. All right. Now the rules for binary acids are, once I see that I just have hydrogen and some nonmetal, it immediately is going to tell me that I need to use the prefix hydro. So I have the prefix hydro, then I'm going to name the anion with an ic ending, and then the word acid. So for this first one, I'm going to use hydro. Then I have the compound, or the element iodine. So I'm going to have iodic. So instead of iodine, I'm going to replace the ion with an ic. And then I'm going to name it acid. For here, I have selenium. So it's going to be hydro. Instead of selenium, I'm going to have selenic. Then acid. Now, the oxyacids, and please excuse my spelling error, will have a polyatomic ion. And all the polyatomic ions that have oxygen in them all end in ate. Carbonate, phosphate, sulfate, chlorate. So instead of using the prefix hydro, we're not going to do that. So if I have H2SO4, this is the polyatomic ion sulfate. I'm going to just take the ate ending and make it an ic and add the word acid. So for sulfate, it's going to be sulfuric acid. If I had chlorate, this would be chloric acid. So let's try some. So HF. This is a binary acid. There's no polyatomic ion there. We'd name this hydrofluoric acid. H3P. Once again, this is a binary acid. We would have hydro. The P is phosphorus, so hydrophosphoric acid. Here I have H2SO4. We have a oxygen, So this is an oxyacid. We don't use the prefix hydro, and we'll just name this sulfuric acid. HClO3, we just talked about. Oxyacid, this would be chloric acid. Now, HCN is one of your polyatomic ions, but it does not contain oxygen. Since it does not contain oxygen, we would consider cyanide. This would be a binary acid. So we'd call it hydrocyanic acid. We'll let you try H2CrO4. You should have all the examples plus this one in your notes along with the flowchart from the previous 2 slides. Now, writing formulas for these, we have to make sure our charges balance out. So we see hydro, so we know this is a binary acid. We know we have hydrogen and we have iodine. +1, -1, we only need one of each to have the charges balance out, so our formula is going to be Hi. Acetic acid does not have the prefix hydro, so we know that we're going to have hydrogen, but we're going to also have one of our polyatomic ions, acetate. Hydrogen's +1, acetate's -1, so our formula is going to be include one of each. We'll let you try carbonic acid, phosphoric acid, hydrobromic acid, as practice problems before you get to class on Tuesday. So if we look at our flowchart, all right, the first question whenever you have a compound, is it ionic, covalent, or an acid? And depending upon which you choose that compound to be, you have a different set of nomenclature rules to follow for each branch. Make sure you do not mix up the different nomenclature rules. Make sure you only follow the rules for whichever branch that you have. Enjoy the rest of your weekend, and I'll see you in class next week.